Hi again, and welcome back to this middle maths video on the applications of the law of sine and cosine. Now, hopefully you've done the lessons for the law of sines and the law of cosines. We did a worksheet before the lockdown that covered specifically the applications of the law of sines. This one covers both the law of sines and the law of cosines. So if you did not complete the other worksheet before, that's okay. If you do this one, you will have covered both bases, and that will be fine. So I have two examples here, and this document is actually posted on the Google Classroom. So I'm going to pause for a minute. If you have access to a printer and you want to print this off so that you can write on it and fill in the questions as I do it, then you can do so. Otherwise, you can just draw these problems in your maths book or whatever paper that you're writing on and work them that way. We will also be using the Desmos calculator that I showed you in a prior video, so that will help you to solve these problems. So first of all, we have this question, and it says to estimate the length of a lake, Caleb starts at one end of the lake and walks 95 meters. He then turns and walks on a new path which is 120 degrees to the direction he was first walking in, and he walks 87 more meters until he arrives at the other end of the lake. Approximately how long is the lake? So basically he's got a lake, he can't measure it all the way across, so what he's going to have to do is kind of go around it. So I'm not going to draw the lake, I'm just going to draw the triangle. So I'm going to draw a triangle like this. Okay, so the lake is down here. Okay, so what he's doing is he is starting at one end of the lake, which would be like right here. He's walking 95 meters, so that is this side right there. He then turns and walks on a new path which is 120 degrees off of the path he was going before, and then he walks 87 meters more until he's at the other end of the lake. So the lake is in here. So this is basically the length of the lake. He can't touch the lake. I mean, he can't, of course, measure the lake with a tape measure. So he's doing it this way. And this is actually how surveyors do these kinds of things. So the question is, how long is the lake? So I'm going to put a question mark where the side is that I want to find. All right. So I'm going to use the rule that I taught you in the last video when it was like which one to choose, law of sines or cosines. The rule says if you know a side and the angle across from that side, you can use the law of sines. Actually, I said it in reverse on the other video. If you know an angle and you know the side across from that angle, you can use the law of sines. That's actually a better way to say it. So looking at this picture, do I know an angle? The answer is yes. I know this angle right here, 120 degrees. And that's the only angle I know. Do I know the side across from it? No, that's actually what I'm solving for. So I cannot use the law of sines on this one. I have to use the law of cosines. So there were two law of cosines. Which one do I use? I use the one that has the side by itself, and that's the one that starts out with a squared. So if you go look at those formulas, this is going to be the law of cosines. You can, now remember, you get to use a formula sheet on this assessment. So these are the kinds of formulas that you will be writing down. This is the one I told you that you must label the angle that you know as A. So I'm going to come in, I'm going to start labeling this in red. The angle I know is A. The other two angles, it does not matter, B and C. So now I need to go and talk about what I know as far as sides go. The side 95 is C, little c. 87 is little b, and I'm actually solving for little a. So the formula says a squared equals b squared plus c squared minus 2 times b times c times the cosine of angle A. Okay, so now we're going to go ahead and start substituting in the values that we know. A is what I don't know, so that's going to stay a squared. B is 87, so 87 squared plus 95 squared minus 2 times B is 87, C is 95, and cosine of 120 degrees. Okay, now you can see that everything on the right side of this equal sign over here is a number. So this whole line can go into the calculator as one thing. So I'm going to go ahead and switch to my calculator, which is right here. And so I will do, clear all, 87 squared plus 95 squared minus 2 times 87 times 95 cosine of 120 and close the bracket. And my answer that it's showing me, I'm going to go ahead and push the blue arrow, 24859. So a squared equals 24859. All right? Now think for a minute, how do you remove the square from the A? Here's my square. How do I take that off? The way I take it off is with a square root. So I'm going to square root both sides. And I get A equals, I'm going to be doing square root of answer. So I switch back to here. I push the square root key. And I push the answer key. And it pulls that 24859 that I had before. And I get 157.7, if I'm going to round it to one decimal place. So A is equal to 157.7, and the length is measured in meters. So this lake is about 157.7 meters long. Once again, we use the law of cosines because we did not know an angle and its opposite side. We had no choice but using the law of cosines. We could not use the law of sines. Now let's move on to the next question. Now, I know some of these worksheets have units of measure that you're not familiar with. You did have a unit on measurements in year 9, way back when, where they actually talked about these kinds of units. I'll refer back to them just so you know. So you can still do this, whether they measure it in yards or in inches or in feet or in miles. It doesn't matter. You should be able to do this. This problem states that points A and B are on opposite sides of the Grand Canyon. The Grand Canyon, for those of you who don't know, is a very popular landmark in the United States. It's in the states of Arizona and New Mexico. It is a very, very big hole in the ground, basically. And it is one of the prettiest natural landmarks in the U.S. And I have been there. It's really great. So we have this huge canyon, and we have 2 points on either side, point A and point B. So I'm going to keep reading. Point C is 200 yards from A, and angle B measures 87 degrees, and angle C measures 67 degrees. What is the distance between A and B? Now, I really can't even picture this in my head, and you do not have to draw these like drawing the canyon or drawing the lake. You can just draw a triangle. You know it's going to be a triangle problem. So what I'm going to do is I'm going to draw a triangle. It doesn't even have to be exactly to scale. Okay? So it says points A and B are on opposite sides of the Grand Canyon. I'm just going to put A and B right there. So the Grand Canyon goes between A and B. So that means that the top angle has to be point angle C. So I'm going to put the C up there. Point C is 200 yards from A. So that means that the distance from C to A, or this side here, is 200 yards. Now, if you don't know, a yard is almost a meter. The difference is very, very small. So anytime you see the word yard, you can think meters if you want to. Now, after it says that, it says angle B measures 87 degrees. So I'm going to put an 87 degrees right there. And angle C measures 67 degrees. Do you now see, once you draw the picture, it makes a lot more sense. Trying to get a picture in your head may not work. If you put it on paper, it makes a lot more sense. What is the distance between A and B? And that is this side down here. So I'm going to put a question mark where they want me to find something. I don't know just yet if that's side A, B, or C. We'll find out in a minute. All right, so what do we have here? We are looking at this problem and saying to ourselves, do we have an angle and its opposite side? So take a second, look at your triangle, and you tell me that. Do I have an angle and its opposite side? Not the angle C. What about the angle B? Angle B is here. Do I have its opposite side? Yes, I do. So that means that I can use the law of sines this time, and that's a much easier law to use. So let's label our sides so we know what we're dealing with. The side I'm looking for is side C. So this is C. What is the 200? It is side B. I don't need to put an A on there. I'm not looking for A, so that's going to just be more confusing. So since I'm looking for a side, remember that when you write the law down, you put the sides on top. It's much easier. So C over the sine of 67 degrees equals, think for a minute, how does the other side look? Write it down. It would be 200 over the sine of 87 degrees. So there's our problem. All right, so let's think back. When we solve the law of sines, or when we solve any problem, we have to get the letter by itself. The letter happens to be where? On top of the fraction. So we've got to remove the bottom of the fraction. How are we going to move this over to this side? We are going to multiply both sides by the sine of 67. I'm writing it in blue so you can tell it's not what I started with, it's what I started working on. And once you do that, those two cancel, and this is just a C over here. So what I see on this side is what is going to go into my calculator. So I'm going to do 200 times the sine of 67 divided by the sine of 87. So I need to clear everything, and I'm going to push 200 times the sine of 67, close the bracket, divided by the sine of 87, and close the bracket. It is so important that you close all of your brackets when you do this. So go ahead and push the blue arrow, and you get 184.4. 184.4. So C is 184.4. And what was our unit of measure? It was yards. So I'm going to put yards right here. The abbreviation happens to be YDS. You could do it either way. All right. So I have shown you two examples. One of the law of sines, one of the law of cosines. Please keep using that rule. Do you know an angle and its opposite side? You need to drill that in your head, write it on your formula page that you're going to use on the assessment. That is the key to doing this. Now, in the Google Classroom, you will have a worksheet that looks like this. It is the law of sines and cosines word problems. If you write small, there's enough room to do the work on this worksheet if you print it out. Please note this. Number 4 is an excellence problem. If you are not going towards excellence, you're going to do either an achieved or a merit. You don't need to worry about this problem. There are 7 questions, so please do all of them. Some of them do get a little complicated, but you can do this. I have an answer key loaded into the Google Classroom as well with all of the problems worked out. Please try to, sometimes it helps to draw the picture as you're talking about it. Look at number 6. It talks about a light shining from the window of a lighthouse. So it may help to draw a cliffside like it says. Draw a little lighthouse on the top. Now, it does talk in some of these problems about what is called an angle of elevation. Okay? You may not be familiar with that term. Let me just talk about it briefly. If you are standing on the ground and you are looking at something way up high, like a balloon going up into the sky, the angle of elevation is the angle at the bottom from the ground towards the balloon. Okay, so in this situation, the angle of elevation is the ground to the top of the lighthouse, the light in the lighthouse. So keep that in mind when you're doing these problems. That's what an angle of elevation is. Let me check and see if there's anything else that you may need to be aware of. Number 4 also talks about angle of elevation, so if you try that problem, that's going to come into play there as well. All right. Word problems can be challenging. Just draw a triangle and see if you can label everything in the correct location. Decide whether you need to use the law of sines or the law of cosines. Set up your problem and work it out. Good luck with this. This is going to be one of the more challenging assignments. And please feel free to email me if you have any questions.